There are 5 objectives for the chapter. Uh, Range from the understanding why we need database management or database relational database, and then we will which will start come from the previous or traditional approach of flat file approach, and also we will have the discussion about the normalization and anomalous issue. We will discuss database design and normalization. We'll talk about the key, the conceptual view and physical view, and also the user's view. Lastly, we'll talk about the features of distributed database. Last week, we did highlight the relational database models, and we mentioned that it is the database models created and projected based on several data tables or database that connected to each other. And we should have two main concepts here. Represent the conceptual and the external schema as it is, as if that data view were truly stored in one table, which is this is the concept that we see as a user's view. We see that it's connected to one table, but the reality that the conceptual view appears to the users that this information is in one big table, but the reality, it is many tables related to each other. So here I bring a small example to see how we have, this is a table where we have invoice table. When we get, let's say we acquire invoice, so the information of invoice ID, customer ID, order ID, product number, and date, time, and status, total, remark, all of this information is not stored in one place. It comes from product table, it comes from customer table, and it comes from order table, and from each one of the tables it will connect and form this table that we view as a users. Okay. So the data modeling concept, the data model is a visual representation of organizations data designed in theory using top-down approach. Top-down approach means we design the data modeling from scratch. The data relations and the relational database is developed and designed from scratch. That's what we mean by top-down approach, which requires detailed analysis of information needed. So means we go to the, we analyze, we do let's say interview questionnaires with the users, internal and external users, to get what is the information needed, and then we process an information analysis. Then from that we come out with the database modeling, with the model that served this information needed. The in practice, which is because we already have many database modeling and so on in the market. So in practice, the many users, many organizations use bottom-on approach or bottom-up approach. Sorry, bottom-up approach, which modified the predefined models. We get models from the market and we try to modify it according to the information needed by the specific or particular company. And when we discuss the database modeling, we should first understand this, the data modeling concept should be based on having entities that create an event. Remember when we talked last week about RAA, resource event agent, and entity relational entity diagram. So that the two approach to data modeling and so on. So just to clarify here, that the entity is anything about which an organization wishes to capture data, either physical or conceptual. And we did explain last week about the graphical technique used to represent models and entity relationship AR diagram, which with each entity in the diagram corresponding to table in physical database. And then we have relations. The relation will describe the situation where the data in one table is related to data in another table. Occurrence describes number of items associated with the entities. Then we will start to discuss the cardinality. And then the attributes are the data element that define in the entities. So I have good example here explaining the relations, occurrence, and attributes entity. For example, we have the entity name here can be person, people, place, object, events, or concepts about which data is to be maintained here. So the example here is let's say car and student, and then the attributes will be the property or the characteristics of the entities, means the description of that entity. So now we know that the color of the car and the name of the student. So student is Jack and the car is blue. And the verb phrase is describing the relationship between these two entities. Association between the instance of one or more entities table. The example here is blue car belongs to the student Jack. Um, what I would like to explain, this is just the concept of the entity relationship, which we discussed in short last week, but here it's the details and basic discussion. But when we talk about RAA is more deep discussion and bring it's advanced and specifically for the accounting recording of the data. In database modeling, we should understand three concepts. First, the association, describing the nature of the functional connection between two entities in a relation. And then the cardinalities. Cardinality is a degree of association between two entities. As we discussed in chapter 10 about the cardinalities, it is representing the number of possible occurrences in one table that are associated with single occurrence in related table. Four basic forms, 0 or 1, and we already explained how we represent it in the diagram, and one and only one, or 0 or many, and 1 or many. Then we have the tuple, is a formal name for row in the table. Someone will ask why we call it tuple. It is a database or programming terminology giving to the row in any database or table. So in this tuple, we should have three main conditions or four main conditions. The value of at least one attribute in each tuple must be a unique. We call it primary key, and other non-key attributes need not to be unique. So only one attribute at least. Sometimes we will have two primary key in one row or one table in case of linked table, as we discussed when we overcome the many to many relations or cardinalities. And then all attributes value in any column must be in the same class. Each column in giving table must be a uniquely named, meaning that the label of each column in one table should be unique from other columns, and tables must conform to the rules of normalization. We will discuss today more details about the normalization and the three levels of normal form 1, normal form 2, and normal form 3. And in normal form 1 we will discuss in short while, but those conditions, especially number this one, all attributes have attributes value in any columns, is one of the condition for normality form 1. And also each column in giving table must be uniquely named, and the last one also is related to it. Okay, so this one is about the cardinality. We did explain last week about this, the relations and so on between two entities, and how we understand this. This is the crow food diagram or representation of the cardinality. So I will not go in details on this because I believe it's well understood by everyone here.
Before we discuss the relational data tables, let's say here what is the foreign keys and what is the primary keys. Generally, the primary key is the identifies related errors. So in this example, we have here the 151 is the primary key for customer table, and it is a foreign key. It is a foreign key in the table of cells. Okay, so you see here the customer is the foreign key in the sales table because it is the primary key that uniquely customers in the customer table. Because of this, the sales table link to the customer table through the customer number. So that's what the difference between the two. So we will see we will see in the next table or next slide more explanation on this matter. So we see here the linkage between relational tables. We see here that the related tables need to be physically connected to achieve data model association, and this cannot be accomplished unless we use the foreign key concept. Okay, so in this example we have four tables. We have customer table, and we have the sales invoice, we have cash receipt, we have line item table, and in this tables we also have a primary key. In each table we have the customer number here is the primary key, and the invoice number is the primary key here, and the remit number is the primary key for cash receipt. And you see here the customer number here is the primary key, but it is here the foreign key. It is the foreign key in this table, so it is the connection between the two tables. And same things goes to the table of sales invoice. Here we see here that the customer number also is the embedded foreign key, where it connected to the customer table. You will see here that this primary key 1875, it is the foreign key here, but it is the connected number connect to the primary key in table customer 1875. Okay, and same goes to the line item table.
Let's have a look here to the relationship of users view and the entities. So user view is the set of data particular user sees, or how they see it. how they say this data. Large organization normally will have thousands of users views. Okay, so in this example we have the entities in the middle. Here you can see, here we have customer, we have sales invoice, we have inventory, and we have vendor. All of those are the entities, uh, tables, entities, database tables. So within the database, it's modeled to have customer tables, to have sales invoice, to have sales, also to have inventory table, and vendors or suppliers. Okay, how the users view of the customer account receivable report, how they get this customer receivable report. They will get it first. They will get information about customers from the customer table, about the name of the customer, the number of the customer. Also they will get some information about the balances from the sales invoice, to form this report. Other than that, also customer credit report will come also from the two source, from customer table and from invoice sales. Sales journal will comes also from the it will come from sales invoice. Okay, and then we have customer sales history report will come from sales invoice. Inventory status report will come from inventory and vendors. Okay, so yeah, this is here it explains the cardinalities between the customers and sales invoice. And when we see one to many, meaning that for one customer, there is many invoices record. Okay, so that explain how this relationship between the redundance of the occurrence of the this association. Okay, so we can generate for one customer many account receivable report if we have this. Okay, so for one customer we will get many a list of sales invoices. Okay, so same thing here. We have many to many, means for many invoices we will have many invoices record. We will have many inventory items, so many to many. Okay, so then we have the relation or the cardinality between inventory and vendors. For one many inventories recorded recorded in the company, it comes from it may come from one vendor. In here we will have an example of conceptual view of the database, how it stores. So we can see here we have dng, and we have gkit, and we have if robots. Those three are customers listed in the customer name, and we have the sales invoice number. We have also the invoice total amount. It would seem like this information may be held in one table, isn't it? In the physical database. However, the data is really stored in a set of 4 related tables. So one table will be for customer, it should be, and one table is for the sales invoice, and one table is for the cash. And the third table, it will be, or the fourth table will be about the inventory, because it's connected to the inventory. Even though when we get the report of customers, table will not show that. So let's have a look in the second. If you see this table, 4 tables are connected using the primary key and the foreign key connection. So in the table of the first table is sales, and it's the primary key here is the sales invoice number, and it's connected to the customer number. So you can see here the customer number 151, which is DNG. DNG is having in here it's connected to two invoice here. If you see here, you will see that NG have two invoice, because this invoice is related to NG, and this one also. Why we see that? Because if you see, it is connected, it mentioned the same customer number. Okay, so that's how we understand this. And then we also in sales invoice for the first invoice, this one for invoice 1.101, we can see that we have two items, item 10 and item 15, and we have the quantity of two of item 10 and two and one for item 50, number 50. Okay, so it's connected to the inventory table, and if you see here the item 10, you will have the more details about item 10, about the price, and also about the description. It is television, and item 50 is microwave. Okay, so to read again this table, to connect it, or to generate as a combined table, you will say that the angel is buying she bought in the invoice 101, she bought TV and microwave with the price of 499 and 499 also, two television and one microwave. Okay, so that's how we connect it. Same will goes to the other customers. So you can see here, we have the Kitty. Kitty is having another again two invoices, and you will see here the invoice number. This two invoice is connected to the items. Let's take the invoice number, this invoice 104. So 104 here is this one, and if you see here 104 is in this invoice the Kitty or Kit, sorry, Kit. Kate is booting the item one of item 40, and item 40, if you go to check what is it in the inventory table, it is range. Okay, and the amount is 789, and so on. Okay, so that's how we explain it. In this table, I will not go in details, because it's explaining what I did explain in details just now. Same goes to this slide also. It's explain how this two items, 10 and 50, is connected to the invoice number 10. Here also is explaining what I did explain just now, in how it's connected that inventory table with the sales inventory, by the quantities and the items number with the other with the inventory descriptions and so on. Why we should have a set of related tables? Why not we just have one table to store all of this data in one table model, rather than a set of separate tables connected to each other through the foreign keys and primary keys and so on. So the answer is, data stored in one large table can be redundant and inefficient, causing the following problems. It will cause what we call database anomalous. And there are three types of anomalous, database anomalous: is update the anomaly, insert anomaly, and delete anomaly. So let's have a deep look into the database anomalies issue. So first is the database update anomaly, which come from the data redundancy in an unnormal or abnormalized table, meaning that when we update the table, we with if it is one table, then we will, and we keep update, some information is already recorded, and we will keep have the what we call the redundancy issue. The second one is the insertion anomaly, sorry, occurs when the data cannot be added to table because of its primary key. And then the deletion anomaly involves the unintentional deletion of the data from tables. So all of this is will cause data anomaly. The existence of database anomalous issue will create improperly normalized tables, which can cause DBMS or database management system processing problems that restrict or deny users access to needed information. So what I mean here by why I bring this table is just to show the normal or unnormal table, or because we have some redundancy in terms of fishes and so on. So it shows that there is unnormals, and sometimes there is a deletion and so on. So in this table, it shows the inventory status report, which is bringing a single view for many information about the part number, descriptions, quantity, on hold, and reordered point, supply number, name of the supplier's address, and telephone. And if you notice here that we have redundancy. Let's say we have Osmint sub. We have the name is redundant here. Let's say Osmint again. We have Bull again. We have here again, and again it's repeated. So same things goes to the address and the phone number here. So this is what we call unnormalized table. Okay, so here it explain how non-attributes are repeated, considered as group repeated. Here we have several descriptions for the same names of the suppliers, and also we have the same number of suppliers here and there. So that is the what we call unnormalized database tables. So we will see how we can overcome this issue by following the steps in normalizing the database tables. Having say about the database anomalous issues, which will cause a problem or issue on normalization table. So we need to understand what is normalization. Normalization is the process of splitting relations into well-structured relations that allow users to insert, delete, and update tuples without introducing database inconsistencies. Okay, so we need to understand that such tables with existing of anomalous issue will exist in tables that are not normalized or normalized at low level, such as first normal form or second normal form of database or of table. We have the optimal normalization table should be a third normal form, which is free from anomaly issues. We will explain those steps in next slides, but we should understand that the normality issue is the process where we have more data connected to each other. Okay. The relational database design rules. First, every column in row must be single valued. Primary key cannot be null. also known as entity integrity. If the foreign key is not null, it must have a value that corresponds to the value of the primary key in another table. All other attributes in the table must be describe the characteristics of the objectives identified by the primary key. Means they describe and related and depend and define the primary key. Lastly, following these rules allows database to be normalized and solves the update, insert, and delete anomalies. Let's say the step. Normalizing tables in relationship database. The normalization process involves removing structural dependencies resulting in third form or third normal form tables that meet the two conditions of normalization. First, all non-keys attributes in the table are dependent on the primary key, and all non-key attributes are independent of other non-key attributes. Having said that, a third normal form table is one in which the primary key wholly and uniquely defines each attributes in the table, and none of the table attributes is defined by an attribute other than the primary key. Let's have a look into the steps in the normalization process. First of all, we should understand that when we have database anomalies, it means that there are indicators of structural problems within the tables, and this structural problems is about the dependencies between the tables. So by having the what we call the row table or the users view table, and normally it include repeating groups of attributes and information. It represents view with a single table. So what we should do to improve the table, this unnormal table, to the table in first normal form, one in F, we should remove the repeating groups. Okay, so we should remove the repeating groups, and we keep only one single information for just to get rid of the repeating groups, and by that we meet the requirement of first normal form. And then we also, in the second step, we need to look into the partial dependency, and in the partial dependency we should remove any partial dependency here to reach to the table in second normal form, and then in the third step is to look into the transitive dependencies in order to reach to table in third normal form. And when we have third normal form table, then we can call this table as normalized table. Okay, so we will go in details and steps by step to each one through an example to make it easy. Here we have the user's view for the sales invoice. We have some information about, we have the information of the about the date, invoice, first the invoice number, the order date, and the shipment date, and also the shaped via the UPS company. And also we have some information about customer number, about details about customer number, customer name, address, as well as the telephone number. Okay, and then we have information about the product. We have description about the product, the quantity, unit price, and we have also the total amount. Okay, so uh, can we store all of this data needed for this view in a single table that also meet the two conditions of the three normal form conditions, which in normalizing process, the step one is to represent the view as a single table that contains all of the view attributes. So we can see here the single structure for sales invoice, a single table. You can see here the primary key is the invoice number, and then we have the all of the information represented through a column. Each information should have a column. So in this is the first step to represent them, and this also to distinguish between redundant data and repeated group data. So after we view and or represent the information or the user's view in a single table structure, as we say here, this and we also differentiate between redundant data and also the repeating group data. So now the step two is to correct the structural dependency by determining if the table contains repeating groups. So we already determine and identify the repeating group data in step one. So we should now separate this repeating groups, which must be removed and placed in a separate table. So you see here, this is representing the now a new table, a separate table, and this one was the redundant information. So this redundant information or redundant data is being in a separate table, and the second table here is the repeating groups. The repeating groups here is the line item tables, and the primary key here is the invoice number and product number. Okay, so step three, to check. So check for the partial dependency, which occur when one or more non-key attributes are dependent on only part of the primary key, may be resolved by splitting table into two. So now what we need to look into the repeating groups table, which is the line item table here, which carry the invoice number, product number, description, and quantity, and also unit price. If you see here, where we said that one of the two conditions of the third normal form of the table is that each attributes should depend on the primary key and not in other non key. So here we have some information uh, like the unit price. Unit price is depend in the product key, and also is partially depends on the description. So in that case, but if you see quantity is depends in the product, the invoice number, and also in the product number. So it is in for the primary key. So accepted. So what we will do now, we will spell out this table into two tables. One table will be for the line item table, which will carry invoice number, product number, and quantity. Okay, which is it meet all of the requirement of the requirement of the normality. And then we the separate table, the second table, which is product number, comes from here, and then description and price, and then we bring this information from the details about the other data not part of this user's view. It is for related to the inventory table. Let's say the date of shipment, the more description or something about the product number, about the product in the inventory. Okay, so by this we made the requirement for second normal form of second normal form table. In step 4, in normalizing process, we should remove the transitive dependency, which happen in table where non-key attributes are dependent on other non-key attributes and independent of the primary key. Okay, so here we see the redundant table. In the redundant tables, sales invoice table, which we get separate, we separated in the beginning in step 2. So we can see here that we have this information up to here is those information are information that is dependent and it depends in the invoice number, the primary key. But those information, telephone numbers, street, city, street address, and so on, is and customer name. All of this information are transitive dependency to the customer number, So it's if we have only customer number, it will represent all of this information. Okay, so in this case we should spell out this table into two tables. One table will be will represent customer table, and the customer we will have this all of this information, and the primary key will be the customer number. And then for the sales invoice table, we will have invoice number and then the other information, which is representing non-key information. So
after we normalize the data, we meet all the normalization. Let's say how is the foreign key or the normalized tables are linked between each other. We already explained it in the previous slides, but let's see again after the normalization. So to work together in the physical database, the tables in the data model need to be linked via the foreign keys, as we say. Okay, so we see here the primary key. The primary key is the customer number, as we say. You see here, and this customer number is the foreign key in sales invoice table. So, but here, what is the difference here? We are more in telling something about the what we call the cardinality. We explain the occurrence. So one to many means one customer customer number has many invoice record. So it may has many invoice here. Okay, so same things goes to the inventory table and the line item table. Here we have the primary key is the product number, and you will see here one product number can have many involved in many line item table, and it is connected, or it is foreign key in the what we call in other table. Okay, so here let's say the key assignment rule. The key assignment rule is about the cardinality in a simple way. So it requires determining the cardinality between the tables and assigning foreign keys. So for example, for this table we have inventory table, and we have the suppliers table. In suppliers table, it represents one, and in the inventory table it represents many, the many side. So you will see here, here we have the suppliers number one. You will see here it's connected one to many items here. Okay, it's connected to many items in the inventory suppliers number to many items or the product number here. Same goes to the suppliers number 22, which is connected to one items, so it can be one or many. So that's how we explain the cardinality key assignment rule for between tables. So here we will see the normalized database table. Here we represent the cardinality in arrows. So you will see here, let's take the example of inventory table, and we when we say here the 3NF mean this table or those tables are meeting the three normal form of normality. So we see here the primary key here is the part number. The part number, let's say here part number 1, it is one to many. One to many. This relation is represent one to many. Sorry. You see for part for one part here, for one primary key, there is it can be represented through three items. Here, three items, three suppliers. It can be. It means that the suppliers, the part supplier link table, which represent it will represent many to many. So you for one part, for part 1, it can be ordered through three suppliers number 22, 24, and 27. So this relation is many to many. It's connected to the suppliers table. Okay, so that is how we explain this. Same goes to the let's say we take the other example is 28, suppliers 28. It represents that you can order one supplier is 28. 28 supplier can supply many items, which is this item number 2, item number 2, and item number 3. And these items, when you see in the table of inventory, item 3 and 2 is here. So we say many to many, because in this table is many, and it connected to this table. What we need to emphasize here is to emphasize with what is the primary key in this table and where it is a foreign key in the other table. So this one is because it is linked table, if you remember. So both are foreign key, but both are also primary key. It's primary key. Both are primary key because they are foreign key also, because this is a linked table. Linked table have no attributes. It's just to overcome the issue of many to many cardinality. After we understand the database modeling and also understand the database relational, how it's connected to each other and so on, now let's move to how the data is managed, how the data system is managed. And to understand how the database is managed, we need to understand the two main approach. The first approach is the flat file data management, where in the flat file approach, users own their data files separately, and the consequence of this is legacy system era problem. What is the problem? Is business culture barriers inhibit entity-wide data integration, data file structure to the unique needs to the primary users. So it is separate database. You see here we have separate database and separate users. So for each users have separate database and software. And this is the traditional approach, and there are many issues related to it in terms of redundancy and other matters that we did explain it in chapter 1 and 2. So let's move to the DBMS approach, or integrated data. You see here in this picture, we see that this is the concept of database approach. You see we have many users and we have many programs, but we have only one database, and this database is integrated and managed by software, separate software called DBMS, or Database Management System. By having this database approach, which is boiling data into a common database shared by all users, it will solve the problems of the data flat files. So it will solve the problem of data redundancy. So no data redundancy, as each data element is only stored once. As such, only a single update procedures is required. Changes on user makes updates the values for all users. Users have access to all firms' data, subject to the authorizations procedures. Database Management System, DBMS, is a special software system that controls access to the database, meaning that this system, or this system software, is controlling the access of the users to the database. How the database do that? Do it through three conceptual models: the hierarchical model, network model, and relational models. The hierarchical and network database are navigational or structured models with data elements using predefined path. The predefined path, meaning that we create we prefine a list of authorization access to the database, and we ask the DBMS to control the connection, the access to the database. And then the next model is, or the third model is the relational models. The relational models, which is flexible and allows users to create a path, to create extra path. Okay. So let's see what form the database. So the database structure is based on files, and this each file is having many records, and these records have many attributes or fields. Okay, so this is an example of customers file. So each database will carry customer file, sales file, and inventory file, and in each customer file we have record of customer 1, we have record of customer 2, we have record 3 for customer 3, and so on. And in each customer record we will have the field or the attributes. We have customer number, we have customer name, street address, and so on. So that's how the hierarchy of the database is structured. Okay, so to simplify, database is involved of files, which is related groups of records. A record is related groups of files, and a file is a field is specific attributes of interest for the entity record, and we can explain it in upside down, that the attributes will form the records, and the record will form the files, and files will form the database. Now let's have a look to the element of the database environment. First, we have users, we have database management system, or DBMS, according to the figures that we showed, that we have users, we have database management systems, and we should have what we call data definition language. Data definition language, or we short form is DDL, which will try to explain or connect the system database management system with the users. Okay, let's have a look to each one of the elements of the database environment. First, users. Users can access the database in two ways. One is direct, via direct inquiry, which requires no formal programs or IBA, or via application programs prepared by system professionals. The second element of the database environment is the DBMS. DBMS help the users access to the database and efficiently manage data resources, includes program development to create database access applications, and backup and recovery database using usage reporting, and also the access. So the database help in first in managing the resources, data resources, through the doing backup and recovery, also by creating the usage reports and access. Also, it helps to connect through the program development to create database access applications. The third element of database environment is data definition language, DDL. DDL defines the physical database to the DBMS on three levels. The first level is the internal view, represent the physical arrangement in the database record, which is how the information or the data is recorded in the physical view or physical nature. And the second view is the conceptual view, or we call it the schema, represents database logically and abstractly, while the third view is the user's view, and we can call it the sub-schema or logical view, defines how users see the portion of the database users is the authorization to the access. Here we have the three views or layers of the database, which defined by DDL, the data definition language. We have the physical layer, or we call it the database view, or the physical database, which is the database designers are generally concerned with the physical view. So this view, where it is how the data is recorded and programmed. And then we have the conceptual view. It is important to understand the concept of the data. This will help in creating queries of the database to create specific conceptual view of the database. And then the external layout view, or we call it end users view. Users of database who need information to make decision will always have a logical view. Now the question is, where is the accounting roles in this three level of views. So the auditor or the accountant is the one who build the conceptual schema with the designers, and also will also create the logical view in terms of if it is about the financial information system, then it will the accountant will contribute to the information needed there, and it will put also contribute to the conceptual view base in terms of the basis, the conceptual basis of the logical view. The figure here describing the elements of the database concepts in a holistic manner. So you will see here we have the element of database environment. We have users, we have the DBMS, and we have the data definition language. So three are here. But how they are interact and connected to each other. First, let's have a look into the system requests. The system request, when especially for the programmers, they are part of the users. So when they develop the system, either they develop the system development process, they will develop the applications, either users program, accounting programs, or marketing programs, and so on. So, and then also they will also be connect to the DBMS as database administrators, and when they are administrate the DBMS, they will create or predefine data definition language in terms of the process of the database management and so on. And then for the other users, they can connect directly to the system through the user's inquiry, just to acquire information. Let's say ordering some information and so on, and this is based on the inquiry language. We will explain it in after a while. And then, but if they are going to manipulate the data, then they need to access through the data manipulation language, which is normally goes through the applications. Through the users can access, do the manipulating the database content through the applications. Okay, so and then there is a host operating system software that interact the DBMS elements with the physical database. The physical database that we say that how the natural content of or the physical view of the data base, which is the concern of the programmers. Now let's look into the Dbms operations. There are 6 operations within the Dbms process. So the operations start by when the users or the users program sends data request or call to the database management system. So what the database will do to this request of data, the Dbms analyze the request by matching the call data elements against the users and the conceptual view. If the request matches, meaning that it is authorized or the users is authorized to access this data or to call this data, and also this the conceptual view is matching the call data elements, then it will process the procedures to the third step of operation. But if not, then the access will be denied. Then if it is processed, if they process, they do analyze and they find the DBMS match the call data elements against the users and conceptual view, and it is pass this analysis. Then DBMS passes the parameters to the operating system, which perform the data interval. Using the appropriate access method, operating system retrieves data from the physical database and store this data in the mini memory buffer area. We call it mini memory buffer area managed by the DBMS, and then DBMS transfers data to users for access and manipulation. And then step 6 is when the processing is complete. Step 4 and 5 are reversed to restore the processed data to the database, meaning that after they recall and update or manipulate, then we need to do again from step 4 forward, step 4, 5 to update the data and store the data. Okay. To explain this more, this diagram is helping to understand also the DBMS operations steps. So we have the 6 steps here. So when the users send, again, when the users send, the users program send the request or call of data, the users here we are in the users view or the sub schema, and you see here with the view of each user's program is different. So this is what we call the sub schema or the user's view, which is specifically for each user's program. Let's say accounting program is different from the data view or the user's view of marketing or human resource and so on. And then the DBMS here, the DBMS, because DBMS data management system will bring all of this sub schema or users view request into the conceptual view. It will be matching the DBMS will analyze this database request or call from the user's program, match the conceptual view with the users, and then if it is okay, this analysis, meaning that it's authorized and the data is matching the conceptual view, and then will call this data or retrieve this data from the internal view. So the descriptions of data structure file based on the organization and access methods, and we then if okay, then through the operation systems or the proper access methods programs will get the database request, and then will be stored in buffer memory, main memory, which is managed by the DBMS as well. And then the application work location will send, because let's say this is the example of user program 1, so they extract and store AB data, which is called by the user's program, and then 6 is connected to the users, and then the step 4 and 5 will be do again when the users update and stored again to the database through the access method programs. Okay, so that's as simple as that. Okay, so now also this just explain in a simple way how 3 users three different users will interact with DBMS. So payroll officer needs access to staff details, customer services the advisor needs access to the customer account, sales manager needs access to the stock levels. So all of them will connect through the DBMS, and here we have what we call subschema or users view. Then what the database will do, DBMS will first analyze this view, analyze the subschema and match it with the conceptual view of the database, and then retrieve the data through a software or proper access method or software, and then store it in temporary memory, let's say to be accessed by payroll officer, and then later on after she finished, then we need to again save this data or store this data in the database in the what we call the physical. Let's talk now about data manipulation and inquiry language, DML. DML is a proprietary programming language that a DBMS use to retrieve, process, and store the data. All user programs may be written in DML, or selected DML comments can be inserted into universal programs, for example, BL/1, COBOL, and Fortran. DBMS query capability. DBMS query capability permits end users and programmers to access data in the database directly. Having mentioned data manipulation and inquiry language, we should talk about SQL commands. What is SQL? IBM's structured query language, SQL, requires far less training and program skills than many languages, meaning that SQL language is the language that communicates with the database. Many commands that allow users to easily input, retrieve, and modify the data. We have many comments that just to simplify and structure the communication between the users, either end users or the programmers through the system. So we have four types of SQL. We have DDL, we have DML, DCL, and TCL. DDL is data definition language. About building the data dictionary, creating the database, describes logical views for each users, specify, record, or file security constraints. So it is kind of the DDL is it's used for the what we call by the administrators, database administrators, or we can say the programmers and software, whereby data manipulation language, DML, enables users to change the content in the database or update it, and DCL enables users to retrieve, sort, and display specific data from database. We call it data control language. And lastly is TCL, transaction control language, enables users to manage transactions in the database. Okay, so let's see what is the comment there. So in the comments related to the DDL is create, alter, drop, translate, comment, rename. So you can see that it's based on it's defining language for the creating database from scratch or modifying the database itself. And then for DML, select, insert, update, delete, merge, call, explain, plan, lock table. So it is about manipulating, and normally is here is the normally is the users or the, let's say, the accountant or the who do this. Okay, and then for DCL is grant, revoke, to control the manipulation, and then transaction control language, commit, rollback, save point, set transaction. So we set that. So this one can be also users, but also managers or top levels can handle the control. Not also IT departments or the software programmers will handle the controls in order to control the manipulation language. Okay, so this is an example of selecting command used to acquire an inventory database. So in the upper table here, we have selected attributes of inventory table. We have a list of items, description, on hand, where is the items, either on hand or the location of the warehouse, unit cost, and vendor's number. Okay, so based on this inquiry or SQL command information, what information being requested? Items, description, on hand, warehouse, and vendor number. And then from where? From which table? Then from inventory. Where on hand should be more than 300, bigger than 300. So if you see here the table, it select three items or 3 lines. So we have 1, 2, and then 3. Why this 3? Because those 3 are the on hand, the others are less than 300 or equal to 300. So select only those 3. And if you notice here, we have not include the cost unit. Why? Because it's not part of the select. It's not part of the select. Only item, the item, description, on hand, and warehouse location, and vendor's number. Okay, and the items is here. So that is how how the database is query language is processed, the manipulation and selection. Okay, so database administration, DBA. Database administration or DBA is responsible for managing database resources. In small company, maybe one individual staff. For big company or large organizations, entire department will be responsible to database and administration, and the responsibility can be categorized into 5. First, planning, designing, implementation, operating, and training. For designing, we design the conceptual and the logical view for the database, and then implementation will create the physical view, and then testing this view, and then training the users to use the database and interact with the database through the applications, programs, and so on. So this table is explaining in details about the functions of the database administration. I will not go through each one of it, but let's have a look into one or two examples. So under database planning, we have developing organizations database storage, then second, defining database environment, defining data requirements, developing data dictionary. So data dictionary is in the planning stage, whereby designing is about designing the logical database schema, where we involve the accountant here also, external users view, sub-schema, internal view of database controls. So that is in the storing functions of the database administration, DBL. And then implementation, operations, maintenance, and changing and growth. So changing and growth is planning for change and growth, upgrading the data, evaluating the new technologies and so on, and try to improve and upgrade the database management and process by the new technology and so on. Okay, so here we have organizational interaction of the DBA. We have the management, we have the system operationals or professional system of professionals, we have end users, we have the operations. So database administrations is interacting with all of these users. So database administration will deal with system professionals in developing the systems and so on, interact with them, and also with the end users, with operations, and as well as with the management for the reporting and so on. Let's have a look to the database administrators functions and duties. So the user's request goes to the database administrators, who evaluate them to determine users' needs and grant access authority. Database administrators creates and maintains the data dictionary, which describes every data elements in the database. The data dictionary is the blueprint of the structure of the database and includes data elements, file types, programs that use the data elements, the outputs, and so on. So we will discuss data dictionary in a short while. So this is an example of data dictionary. You will see here, let's say we have this is the field name, lesson ID. So what is the data type? The data is integral, meaning that it is either to be the data form, it's either to be number and can be number and can be also alphabet. And the data format is NN. Can be, you can put the format here just to restrict the KN, and the field size you put only 6 digit. Description, unique number of ID for all drivers, so cannot be two numbers. So this is example. Username, so it is tags, no data format, but the field size is let's say you put 20 alphabet, and then surname for the drivers. This is the example, and so on. First name, address, and you see, let's say birth of date of birth. So it is the data type is data date and time. So you have, this is the format, and you put the field size or characters, and then you put the driver of the birth as a description, and then you put example. So that is how we what is the database dictionary look like. The relational database are based on the index sequential file structure. So this index sequential file structure facilitates both direct access to individual records and batch processing of the entire files. Multiple index can be used to create a cross-reference or inverted list, which allows even more flexible. So this figure is illustrating the index sequential file. So for example, in here we in this table and this table we have no sequential value. So the key value here is the number of the transaction, let's say, and here is the record address 1 2 3 4 5, and then for the employee table is showing that the employee number, which is the employee number and name, address, skill code, and the earning. But in this table, which is the UTD earning index, is the key value is the is what we call is the sequential index based on the value of the amount. So you will see here it's start from the big to the small. So this is the sequential index table. So this is one of the one of the function of the database administration. As you'll see here, so even though this is now this is based on the value is 3, but it create cross reference to other tables in different place. Okay, so that's how what we mean by index sequential files. This is another example to show that the data record in different data block in memory based on the, let's say, the value based on what we request to have what index we set up for the database. Okay, indexing sequential file depicts or describes data in a form of two-dimensional tables, support the relational algebra functions of the restrict, project, and join. Those three functions, algebra functions, help to acquire the information and create the reports. Okay, so restrict mean extract specific rows from specific table. Project extract specified attributes or columns from a table to create a virtual table. And join build a new physical table from two tables consistent of all contented pairs or rows from each table. So here in this table we have column, we have tuple. A tuple is the row. It's the IT terminology or database terminology for row. Tuple 1, tuple 2, tuple 3, and so on. And attributes is represent the column, or we can see column. Okay, so when we have one attribute, so we will call it a single attribute key. Okay, but if we have two attributes, so we will call it composite key, one A plus B. But if we have three and more attributes, then we will call it multi-attributes or composite key. Okay, so you will see here this is also explaining the relational table called customer. So we have here it's the attribute, as we said. Each column is represent an attributes for the data. So table name is the customer, so this attributes or we call it the columns. And we have the tuples is representing each row here. So this differentiation or definitions defining the data based on this structure it helps to the extracting or acquiring information with more flexibility and cross reference and so on. So that's why we call it the relational data base modeling. So this explain the relational algebra functions of restrict, project, and join. So as we say that restrict means extracting specified rows from specified tables. So we just take the file. This is how the programmers is managing and designing and modeling the database. And then project is just about the columns, and join, as we said, is building a new physical table from two tables consisting of other rows and pairs from each. Okay, so now we will move to a new concept talking about the accountant and database modeling. Accountant should understand the data normalization process and be able to determine whether a database is properly normalized, and understand also the anomalous issue. So update anomalous can generate conflicting and absolute database values. The accountant should understand that, and insertion anomalous can result in recorded transactions and incomplete audit trails. And deletion anomalous can cause the loss of accounting records and the destruction of the audit trails as well. Organization's database may consist of thousands of normalized database and navigations of the networking require understanding of data structures. Here is the broad types of database. We have centralized database, we have the distributed database, we have cloud database, NoSQL database, relational database, network database, hierarchical database, and object-oriented database. What we will focus on now is in the database, in centralized database and distributed database, just to explain the function of it, how it is. We will not go in details on the other types, because we for relational database we did explain the concept of it in early slides and so on. But for cloud database, network database, and so on, we may highlight some of it on the appendix of the end of this lecture, but not in deep explanation, because it's more to the functions, more to the IT matters. It's not affecting the accounting concept. Centralized database, where we have the database in one location, and we have many what we call users to communicate through the DBMS to connect to that central database type. So the centralized database approach, remote users send requests via terminals for data to the central site, which processes the request and transmits data back to the user. Whereby distributed environment, where the distributed data processing DDP is an alternative to the centralized approach. What we mean by centralized database, the centralized database is achieving data currency. Data files accurately reflect the effect of transaction. Is critical but challenging with distributed data processing. So during data processing, account balances pass through a state of temporary inconsistency in which values are incorrectly stated. To achieve data currency, simultaneous access or same time access to data elements by multiple sites must be prevented, meaning that since we are using distributed database, we need to have to manage the same time access from different users in the same time. Solution is to use database lockout. Database lockout is a software control and prevent the multiple simultaneous in the distributed database. Partitioned database approach split the central database into segments that are distributed to primary users. Storing data at local site increases users' control, permitting local access to data and reducing volume of data that must be transferred between sites improves the response time. And also the partitioned database reduce potential for destroy or disaster as losses at a single site cannot terminate all of the organization's data processing. Meaning that, let's say we store the data in distributed database approach, so you keep some data in, let's say, in one site, location 1, location 2, and so on. So different data is stored in different distributed different location. And let's say it happened that some disaster happened, flood or some fire issue with that one side of the problem, so the losses is only for that single site and not to the other side of database. So this is what we call partitioned database, where we have site 1, site 2, and site 3. Three of them are, if you see here, we have different database, EB, EF, and we have CD, different database handled by each site users. So the database partitioned approach is communicating this data. If, let's say, the set 2 is requesting for data, let's say A, so it will goes here to request the data, then the data will goes to this side, and then again, if any, so you can see that there is arrow in and out for each site. Okay. So also for distributed database, as we said, there is a possible that the multiple sets will lock each other out and prevent transaction processing. So when one site has request and or locked data and another site needs to access the same data, a deadlock occurs because there is multiple exclusion to the data. So this can result in incomplete processing and database corruption. To resolve that, resolving the issue of deadlock usually involves sacrificing one or more transactions which must be terminated to complete the processing of other transaction in deadlocked. The decision influenced by resource currently invested in the transaction, transactions stage of completion, number of deadlock associated with the transaction. So in easy way, so let's say we have two set users is accessing in the same time one data. Okay, so in that case, so one of them should be cancelled and delete their update, cancel their update based on what? Based on this three elements, okay, factors. So the first factors based on the value of the transaction, based on the value of the process or invest, and the second one based on the stage, which one is more about to complete more. So we will cancel the list. So also in terms of the number of deadlocks association with that transaction. So this diagram is or figure explaining the deadlock conditions. So look A will let's say if we have let's say the site in site 1 there is a request from site 3 to use the data EB. So A will lock and keep C in waiting, and also will allow the access of the data for E for 3, and then after that we'll send the data to the updated data to the site 2. Okay. One of the issues also related to the distributed database is the replicated database. Replicated databases exist when entire database is replicated at each site. So effective when there is a high degree of data sharing but no primary user. So primary justifications is to support read-only query. Problem raises when local sites need to update the replicated data with transaction. Database concurrencies is the presence of complete and accurate data at all remote sites. Commonly used methods of concurrency control is to serialize the transaction using classes and timestamps. Okay, so this is what is the replication database approach, meaning that we have different sets and we have the same data in each sets. So each site we have the same data here and each site. So that's the different approach of distributed data. So this is also just to illustrate the replication database update in dependency. Let's say in set A and set B we have the update of account receivable control starting balance of 10,000, and then site A. In site A they have sold to Jones by 2,000, so they update the account receivable control account in the database, which now it is 12,000, and then for set B they update the sales to Smith by 1,000, so their database has been updated, the account receivable by the 1,000, so it is now 11,000. So this will create database inconsistency, and then we will have what we call timestamp. To overcome this is we should have timestamp to update the data in one set, then goes again to this balance and update the database for all. So it can be like this replicated, but it should have what we call concurrency to keep the data updated. Okay, so about to finish today long class. but before that we will talk just in a fast way. We will go through the some approaches of database. Again, here we will talk about the distributed databases and accountant. So the decision to apply distributed database should pass into a thoroughly planning and analyzing to reach to this approach. So many issues and trade-offs to consider, including should organizations data be centralized or distributed? If distributed, should database be replicated or partitioned? If replicated, should there be total or partial replication? If partitions, how should the data segment be allocated among the sites? The choices made impact the organization's ability to maintain database integrity, preserve the audit trails, and have accurate accounting records. So should be consider all of this because it will affect the accounting records and also functions like audit trails and so on. Here is some features about the structured database. So talking about hierarchical database model, we will not go in details on this, but it's can be explained on the from the diagram next. So the hierarchical data model is based on based on having a father file or root segment file, and then we have files, sub files down, and then we can call it parent file and child, and then this child will be parent for other file and so on. So that's how the hierarchical database modeling. You can see here this the example of portion of hierarchical database. You have customer file, and then in customer file we have cash receipt file, and then we have here sales invoice file, and then line time files and so on. Okay, that's how it connected in terms of hierarchical database. Then we have the network database model. You can see here the multiple parent association, that one file, one child file can have more than one parent file. That's the main difference between the hierarchical. Here you see the hierarchical database model, where we have for each parent file we will have one child, whereby for the filing or multiple database models we have multiple parent file. That's something about modeling and so on. Then we go for the data structuring. We have different type of structuring. We have graphic, we have tree, we have sorting, we have linked list, we have list, we have spinning tree, we have hashing, we have stack and graphs. So all of this kind of database are database structures are the bricks and mortar for the database. The hierarchical database structure use the hierarchical indexing direct access methods. So as we said, the root segment of the database is organized as index file, then the lower level is recorded as a pointer and linked to the segment or index file. The network model data structure is also navigational database with pointer, creating explicit linkage between records. Lastly, talking about linkage between files in hierarchical database, we did explain this in details, showing that how it's connected by the foreign keys and so on, but here we explain it based on the database modeling approach. Okay, so I think that's all. So to recap, In general, this chapter is quite comprehensive, covering many aspects of database. We first talk about database concept and relational database. We talk about the database modeling and try to link what we discussed in the beginning of this class with the previous or last week class. And then after that we move discussing the database management. We talk about DBMS, how it's operate, the 6 steps of operations. We did also explain the types of the database operations. We explain also the DML, or the element of database environment, which is the users and the DBMS and the DDL or data definition language. And then we explain what DDL. We explain also the SQL structured inquiry language, and we explain what is it. It is facilitating the language between the users and DBMS. I believe that's the main concept we should focus on. The rest, what have been explained about the type of database, I believe it's not that important for us as accounting to understand. That's all for today, and see you inshallah next week for the discussion. If you have any questions, please write it down in the comment of the video in the YouTube channel. Then I will try to address it in the class. Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh.